On slide 98, we turn to step 4, model 2, where we're going to add a Lag0 effect from tired to PA, so the same time point effect. But we still are going to have the cross-lagged analysis of PA and tired. So we have the cross-lagged situation as before, but now we have a direct arrow here from tired at time point t to PA at time point t. And that's easily added in the within statement, and that is we just mention the variable tired without any ampersand. That means the contemporaneous effect of tired on PA. But we keep the lagged effect to see if there is an important lagged effect still. And then tired is like before, regressed on tired at previous time point and PA at the previous time point. Slide 98, then you have the standardized estimate, both without and with this Lag0 effect. So the top part of the panel repeats what we saw before when we only used Lag1 effects, a small effect on of tired on PA, small but significant in a standardized metric. Adding a Lag0 effect, we find that that is more than twice as big as the lagged effect. And now the lagged effect is insignificant. So what matters is how tired you feel now, influencing your positive affect, not how tired you were a couple of hours ago. On slide 100, we turn to RDSEM. So I call that model 3 of step 4. So we're going to contrast RDSEM with the regular DSEM. And we're going to consider the within level part of the model. So we have continuous latent variables here, all circles, on the within level. We're going to simplify the model that we talked about in the earlier slide. We're going to delete all of the cross-lagged effects and just talk about the contemporaneous effects, which were the big ones, or bigger ones. So we have then a simple model, PA on tired, that's that regression, and PA on itself, that's the autoregressive part or dynamic part of the model, and tired on tired and tired at the previous time point, the autoregression for tired. Now for RDSEM, we changed the model. We no longer have these dynamic autoregressive relationships between the variables themselves. We still have PA on tired, but now we're going to instead consider the residual of PA after we've regressed on tired and say that that residual is regressed on the residual of PA t minus 1, which is the residual in the regression at the previous time point. So this is a linear regression for the residuals, so it has its own residual. And we do the same thing for tired. So substantively, this is a different thinking of the processes. PA on tired is specified like before, but this residual now is specified as PA hat, regressed on PA hat 1, which is one lagged earlier, one time point earlier. Same thing for tired. So RDSEM is more like regular two-level analysis, where we focus on regressing PA on tired, and we have no lagged effects, by which I mean these dynamic effects between the variables themselves, but instead we have auto-correlated or auto-regressed residuals at the top here, the hat variables. Now RDSEM is the same as DSEM if you have no covariates, as you can imagine, covariate being tired in this case. On slide 101, we compare the two models from a more substantive perspective. So DSEM on the left here, apart from tired influencing PA contemporaneously in both models, the two models say different things, have different implications. For DSEM, we're talking about an indirect influence of tired at t minus 1 through PA at t minus 1 to PA at time t. For RDSEM, it's only the residual of PA PA t minus 1 that influences the residual of PA at time t, and therefore PA itself at time t. So there's no indirect effect of tired to PA to PA. So two different interpretations. One, you believe that the previous value of PA influences PA, or you believe that it's only a residual correlation between the two, residual regression. So this is a regression for that residual, regressed on that residual with a residual. It's a linear auto regression of the residuals. And the two models do give different estimates of the regression of prime interest, namely the contemporaneous effect of tired on PA. There's a fairly small difference in this example, but that's not always the case. There's an interesting paper on this, comparison of models for the analysis of intensive longitudinal data in the RDSEM journal. And the text around tables 6 and 7 is particularly interesting because it raises the question of whether or not you need to model the covariate here. You need to model the auto-regression or auto-correlation of residuals for the covariate under situations of missingness and under situations of different contextual effect. That is, when we have a regression of PA on tired also on the between level. This is all for the within level, to remind you. So the conclusion in those tables is that this is necessary to include for both DSEM and RDSEM to get correct estimates and standard errors. If you have missing data or if you have a contextual effect, that is the within regression being different than the between regression. So I recommend that paper. Now RDSEM is useful for many things. For instance, I've used it a lot to study the relationship between two outcomes, controlling for covariates that are a function of time, like a trend, a downwards or upwards trend, or a up and down trend, such as daily cycles. Now, with this situation of RDSEM, we can extend that a little bit. So we're looking at RDSEM here. You recognize it because there's no direct effects, no autoregressive effects, only for the residuals. You can have a random slope for this relationship. And on between then, you will have 3 continuous latent variables, and you can regress each of them, the random intercept for PA and tired and the random slope on the 2 covariates that we used before, SDQ and GRL. And the RDSEM input then for that fuller model would be like this. Still T interval 2, and we have these between level covariates, and we do the gram mean centering of the SDQ covariate, and it's 2 level random still. And the only difference comes in here. We have a random slope, PA on tired, and we allow the residuals, the hat variables, to be regressed on each other for both PA and for tired. So no ampersands here on the right hand side, but instead hat variables, residuals being involved. And then you can regress PA and tired and S on the 2 covariates and allow their residuals to be correlated on the between. And here are the estimates. So here are the standardized estimates, and since we have and it's within level, and since we have random slopes, there will be the individually standardized estimates averaged over clusters, averaged over people. So let's focus on this PA on tired regression. That's the main thing here. And we see that it has a negative coefficient minus 0.199, on average significant. And just to remind you, it was minus 0.193 when that coefficient was fixed. And on between, we see that S on SDQ has a negative effect, which is significant, and saying that as the childhood emotional problems variable increases, S gets smaller. S gets smaller. So there's an influence of SDQ on the random slope. So then you have to figure out what that means substantively. On the next slide, then, we take the tack of trying out mediation. So we are interested in PA related to tired, and interested in PA related to, say, SDQ. But we are also interested in tired related to SDQ. So we have this little triangle here of an effect of SDQ on PA that's direct and indirect this way. So this is on the between level now. So we have mediation on between, PA on tired and the covariates, and tired on the covariates. And we can also add S on tired and covariates, and a correlation between the two dependent variables here. So the standardized between level estimates then would be PA on tired minus 0.435, and then tired on SDQ 0.228. So the product of those two would be the indirect effect controlling for gender. So that's 0.2 times 0.4, so that's 0.08, or maybe minus 0.09, which is then smaller than the direct effect PA on SDQ, the direct effect here. But that's how you can think about it, showing the facility of a mediation model on between, if you want to.